In this lesson, we will focus on how to define and create a probability distribution function, or PDF for short, as well as define and create an abbreviated PDF for a discrete random variable to answer questions about the random variable. We will also create a probability histogram and a cumulative probability histogram. As stated in the book, The Practice of Statistics, a probability distribution function, or PDF, for a discrete random variable is a chart that displays all the values that the specific variable can take on the associated probabilities. Let's look at an example. This is an example of a probability distribution function. It's a chart where the top row tells you all the values that x could take on. In this case, the values are 0, 1, 2, 3, 4, or 5. Underneath, in the second row, is the probability that each one of those values would occur. For example, the probability that a person would have 0 siblings is 0.14 in this distribution. The probability that a person would have 3 siblings is 0.17, and so on. A couple of things to remember about a probability distribution is 1, all of our probabilities have to be between 0 and 1 inclusive. That hasn't changed from the other lesson on this topic. And 2, if I add up the second row, the probability row, those should all add up to 1. So, if in an example, you're given all but one of the probabilities, you can find out what that missing probability is by taking 1 minus all the other probabilities. Let's try an example. In example number 1, 3 coins are tossed. Let x represent the number of coins landing heads up when tossing 3 coins. Complete the following. A. Create a probability distribution function for x. B. Find the probability that x equals 0. C. Find the probability that x is greater than 1. D. Find the probability that x is less than or equal to 2. And E. Draw a probability histogram for x. Remember, x is defined to be the number of coins landing heads up when tossing 3 coins. So what are our choices for x? Well, if I toss 3 coins, how many could land heads up? 0 coins could land heads up if all 3 tails happen. Or I could get 1 out of 3 coins as heads up, or 2 or 3. So the possible values for x are 0, 1, 2, and 3. Now, what's the probability of each of these occurring? What will really help us is to look at the sample space that we learned in the probability lesson on key terms and ideas. You could draw a tree diagram if you'd like to get all 8 of these different outcomes. Now, looking at these 8 different outcomes, how many had 0 heads? There's just 1 out of the 8 that have tails, tails, tails. Thus, the probability of x being 0 is 1/8. Now let's look at the other side of the coin, no pun intended. The number of coins that land 3 heads up is only 1 out of 8 because there's only one way to get heads, heads, heads. So I know those 2 probabilities are 1/8 and 1/8. Let's look at x equals 1. How many of our 8 choices have only 1 heads up? I see HTT, I see THT, and I see TTH. So there's 3 out of the 8 outcomes that have 1 heads up. Now you have 2 choices to find this last probability. The first choice is to count how many have 2 heads up. Your second choice is you know that these probabilities have to add up to 1. So right now, if I add 1/8 and 3/8 and 1/8, that gives me 5/8. If I subtract that from 1, that gives me 3/8. And that completes my probability distribution for part A. I'll use this probability distribution to answer the rest of the questions. B says, find the probability that x equals 0. I just need to look at my chart, and that tells me the probability that x is 0 is 1/8. Now what about for part C? Find the probability x is greater than 1. It's very important to look at our symbols. This says greater than 1, so that means 2 or 3. The probability that x equals 2 or 3 is 3/8 plus 1/8, or 4/8. Part D says find the probability that x is less than or equal to 2. That means x could be 2, or 1, or 0. So I'm looking at this part of my distribution function. If I add these 3 probabilities together, I get 7/8. Our last part, E, says draw a probability histogram for x. Nothing has changed in regards to drawing histograms since our first lesson on histograms. You still need to label your x-axis and your y-axis. But in this case, our x-axis is the number of heads, which is x. And our y-axis is our p of x, or our probability of that happening. Well, what could x be? In this case, x could be 0, 1, 2, or 3. So that's what I need to be labeled on my x-axis. On my y-axis, my probabilities go up to 3/8. So I need to scale my axis so 3/8 is readily available. I've decided to scale in eighths. I have 1/8, 2/8, and 3/8. Now I just draw my histogram like I've always done. And this is the probability histogram for our random variable x. Now let's try another example. In example number 2, suppose you are playing a game with your friends. You roll a 6-sided die. If a 1 or a 2 comes up, you win $10. If a 3 comes up, you win $20. If anything else comes up, you win $0. Let the random variable of x represent the amount of money you win on any given turn. Complete the following. A, create a probability distribution function for x. B, find the probability that x equals 10. C, find the probability that x is greater than 0. D, find the probability that x equals 8. E, find the probability that x is less than or equal to 15. F, draw a probability histogram for x. And G, draw a cumulative probability histogram for x. Pause the video to try this on your own. Press play when you're ready to continue. Here's a solution for example 2. The first thing you want to recognize is what does our random variable x represent? In this case, the problem tells you that x represents the amount won on any given turn. So what are your choices for how much you win? You could win $0, $10, or $20 on any given turn. Now, what are the probabilities if that happens? If you recall, you win $0 if a 4, 5, or 6 comes up. Well, that's the probability that when you roll a die, you get a 4, 5, or 6. That's 3/6. What's the probability that you win $10? Well, you win $10 if a 1 or a 2 shows up. There's only 2 out of 6 ways for that to happen. And you win the big bucks, $20, if a 3 comes up. There's only 1 out of 6 ways for a 3 to come up. So this is your probability distribution for our random variable x. Now to complete part B, we need to just find probability that x equals 10. Using this distribution, the answer is very easy to see. Just looking at the chart, you can see that it's 2/6. Part C says, find the probability that x is greater than 0. That does not include 0, so I want the 10 or the 20. Together, that would be 2/6 plus 1/6, which is 3/6. Part D says, find the probability that x equals 8. This means, what's the probability that you win $8 on any given turn? Well, isn't that impossible? You can only win 0, 10, or 20. Thus, the probability that x equals 8 is 0. For part E, we need to find the probability that x is less than or equal to 15. Be careful here. Just because 15 isn't in our probability distribution, that doesn't mean the answer to this one is also 0. I want you to know the probability of winning less than or equal to $15. Well, that includes 0 and 10. So the probability that I win 0 or $10 is 3/6 plus 2/6, which is 5/6. Before I move on, I want to stress the importance of making a really good probability distribution. If you noticed, I used the chart to answer the rest of these questions so far. So make sure you spend a good amount of time on making sure your probability distribution is accurate. I'll use a probability distribution to draw my histogram for part F and part G. First, here's part F. As I did in the first example, I'll label my axis with x and p of x. X in this case is the amount that I win. That could be 0, 10, or $20. In this case, my probabilities are really in terms of sixths, so I scale in terms of sixths. I should get a histogram that looks something like this. If you're fraction phobic and you want to use decimals instead, that's okay. You'll just have decimals instead of fractions in your histogram and your probability distribution. For part G, we need to draw a cumulative probability histogram for x. First, we need to remind ourselves what cumulative means. It's everything up to and including. So, what I'll do is actually add a row to our probability distribution, and I'll label it C of x, or the cumulative probability of x. What I'll do here is look at what's the probability that I get a 0 or less. Well, that's only 3/6, because the lowest I can get is 0. But the next column over, the $10 column, in the cumulative row, that means what's the probability I win $10 or less? Well, what I need to do is add up everything up to and including the probabilities for 10. So I'll add the probability for 0 and the probability for 10 to get 3/6 plus 2/6, which is 5/6. Lastly, for $20, what's the probability that I win less than or equal to $20? Well, that would be everything in my distribution. So that'll always be 1. That last element of C of x will be 1. Now I'll draw my histogram, but I'll use the top row and C of x, the bottom row, to make my histogram. The x-axis is labeled just as I had before, with 0, 10, and 20. But my C of x will always go up to 1 because my last element will always be 1. Once I have it labeled, I'll draw my histogram based on my probability distribution. I get something that looks like this. Now let's test what you've learned so far with a check for understanding. A student is taking a 4-point quiz. Let Y represent the number of points a student receives. The student has a 30% chance of receiving 4 points, 25% chance of receiving 3 points, a 15% chance of receiving 2 points. A student has the same chance of receiving 1 point as he does of receiving 0 points. Based on the information provided, complete the following. A, create a probability distribution function for x. B, find the probability y equals 1. C, find the probability that y is greater than 2. And D, find the probability that a student receives at most 2 points on the quiz. Pause the video to work on this. Press play when you're ready to resume. Here's the solution to this check for understanding. As you see here, this is the probability distribution you should have created for part A. I didn't give you the probability of getting 0 or 1 points, but I did tell you it was the same. Since I know that all the probabilities have to add up to 1, I can figure out those two probabilities. The answers to part B, C, and D are here. They're based on the probability distribution that you just drew. Now it's time for the wrap-up. After this lesson, you should be able to define and create a probability distribution function, or PDF, for a discrete random variable. You should be able to use this PDF to answer questions about random variables, to create a probability histogram, and to create a cumulative probability histogram. We'll continue to use these ideas in other lessons. That concludes this lesson on probability distribution functions for a discrete random variable. Remember, you can review this video as many times as needed for better understanding. Thanks for watching.